Okay.
Page 420 minus 18. Page 402. The water alone. The force needed to lift the water is equal to the water's weight, which decreases steadily from 70 newtons to 0 newtons over the 20-meter lift. When the bucket is xm off the ground, the water weighs f of x equals 70 times 20 minus x over 20 equals 70 times 1 minus x over 20 equals 70 minus 3.5 xn. The work done is W equals integral from a to b of f of x dx, where a is 0 and b is 20. I'm really not following this. Oh. I need my olives. Now.
Okay. Today in Olive's workshop, we are going to cover how to use work-related problems in real life. So, we're going to talk about the work it takes to lift a leaky bucket. And because a bucket alone has a constant weight or force, we're just going to talk about the water alone. So, in this case, we will use the Olive method, as it is Olive's workshop. Now there's some information that we need to have before starting the Olive method, so I'm going to read the given information from the problem. It is given that the water and the bucket will be lifted from 0 to 20 meters off the ground. And it is also given that the bucket starts out, the initial weight, we'll call that weight sub 1, is 70 newtons of water. Now it also says that when the bucket reaches the top, reaches 20 meters above the ground, that all of the water has drained. So water sub 2 equals 0 newtons. We with me? Alright, here we go. The Olive method entails using a graph to represent the work done. So I'll draw the x and y axes here, and we are going to allow the x-axis to be meters and the y-axis to be newtons. So remember, we are trying to find the work. Work equals newtons times meters. So we can already see that our work is going to be found by multiplying the two axes or finding the area beneath the curve. So here we go. We have 2 points on this graph so far. The point at which the bucket and water start, which is at height 0 meters, Newton 70. Point 1. Our second point is going to be when the bucket has reached the top, 20 meters, and there are 0 newtons left. So here we go. Over 0 meters up to 70 newtons. Over 20 meters up 0 newtons. Here is the graph of the position of the newtons and meters of the water. So, to find the area beneath the curve, we use the integral. Just going to move on to another piece of paper. Before we find the integral, however, we have to be able to find the equation of the curve. So again, I'm going to write out our 2 points.
The equation of the line, you mean?
Yes, in this case it is, the curve is a line. It is a constant rate of change. So here are our 2 points, and since we know it's a line because it's a constant rate of change, we know that the equation for a line with 2 points, you can say y minus y1 equals slope times x minus x1. So we have our y1 and our x1. And we can easily find the slope by saying the change in y over change in x, which is going to equal 70 minus 0 over 0 minus 20. It's going to equal negative 7 halves is our slope. So here we go. Y minus, we'll just use this point here. It's our first one. So here all we have to do is simplify now. So over here we have negative 7 halves x. Bring the 70 to the other side. There's the equation of our line.
Cool.
So now that we have the equation of the line, we can find the area beneath it by taking the integral. So we'll take the integral from 0 to 20 meters, because that's how high we're lifting the water, of our equation. Don't forget the dx. Alright, I'm just going to move again to another piece of paper. If you can just see that bottom integral right there. Alright, now we're going to evaluate the integral. So we have...
Couldn't we just take the area of the triangle?
Yes, because it is a line, you can't take the area of a triangle.
Oh,
But this is how you do it for a general curve.
Oh, because if it was curved, I wouldn't be able to just find it as easily.
Exactly. So here we go. I'm just going to show you this method so that we can do it in any situation. So we're going to raise the power by 1, divide it by the new power, which is the same as multiplying it by 1 over 2. We'll simplify this later. Raise the power by 1 and divide it by 1. Evaluating this from 0 to 20, so we don't need the c. So here, we'll simplify this over here. We have negative 7/4 x squared plus 70x, evaluated from 0 to 20. And let's just plug that right in. And since this is a polynomial, we know that if we plug in 0, we're just going to get out 0, so we can ignore that part of the problem. So here we go. We have continue to simplify. We can cross out these 4s. That turns into a 1. Negative 700 plus 1400. Final answer is going to be 700 Newton meters, which, if you know some physics, is the same as joules.
Awesome. I feel so enlightened. Thanks, Olive. The Olive method really worked.
So if you ever find yourself in a situation like this,
I'm so frustrated.
just know that there is always an olive branch in reach. Just look up.
The Olive method! Oh, my friend Olivia taught me. Okay, so they give me that the height that I'm traveling is 20 meters, and I'm starting at a weight of 70, and I'm ending at a weight of 0. I can plot my points, and I get a triangle. And what I'm trying to do is find the area underneath the triangle to find what the work is, because work is newtons times meters. So I plot my points at over 0 up 70 and over 20 up 0, and then what I want to do is find the equation of the line so I can take the integral to find the area underneath. So in order to find that equation, I use slope-intercept form, which is y minus y sub 1 equals m times x minus x sub 1. Y sub 1 is 70, and x sub 1 is 0, and my slope is found by doing the change in y over the change in x, which is negative 7 halves. That gives me y equals negative 7 halves x plus 70. Now once I have what that line is, all I need to do is take the integral from 0 to 20, and I found what that area is of that triangle. So, in order to take the integral, I do negative 7 halves x squared plus times 1 half plus 70x evaluated from 0 to 20, And because a polynomial times 0 is just 0, I don't even have to evaluate that. I just evaluate it for 20. And when I evaluate for 20, I get negative 700 plus 1400, which equals 700 joules. Thanks, Olive!